Hi everyone, today we're going to be talking about the different types of triangles. Now, I know triangles may seem like something that might not need much thinking about, but triangles too have a lot of stuff to understand about. One of these such things are the different types of triangles. So there are 6 different types of triangles. 6 types of triangles. And today, we're going to be learning about all 6 of these triangles. But to do that, we're going to have to learn a few different basic concepts first. So one of that is angles. So to understand angles, let's take 2 different line segments. This is our first one, and this is our second one. So these are our line segments, and let's name them AB. So this one is AB. And let's name them the other one C and D, CD. So over here, our line segments are AB and CD. Now, whenever we have a line segment, it's usually denoted by a small line above the name of the line, so we can tell that it is a line. Now, let's talk about angles. So you see how both of these lines intersecting formed 4 angles. One between A and D and one between C and B. The other 2 are between B and D, and the last one is between A and C. So you see did you notice how I said between A and C? Or between A and D, or D or B, or C and B? Well, that really helps us to name these angles. So over here, as you see, A and D both form and intersect. We forgot to name the intersecting point. Let's call it P. So they intersect at P and form the angle AD. So let's write down our angles. So as I said before, remember how there's that small line between a line segment above a line segment's name? Well, the same thing happens for angles, except instead of a line, we have this weird half triangle thingy. So that shows us that it's an angle and not a line or anything other. So our other angles are formed by C and B. So we'll call that one angle CB. And our last 2 ones are formed by D and B. So we'll call it DB or BD. And our last one is formed by A and C. So if you think about it, it doesn't really matter which order we're putting the lines in. So let's say we had an angle, so let's say we had a random angle and they intersect at this point. So let's call this A, B, and C. Probably the most basic angle name, but that's not our focus over here. So our angle over here is ABC, angle ABC. So if you notice, if we called this CBA. CBA and ABC are practically the same thing. Because no matter which order you put it in, if you go from A to C, or if you go from C to A, you still get the same thing. So angle CBA and angle ABC are the same thing. But then if we say BAC, do you think that would work? No, because that would show us going from B to A and then going back to C somehow. So that is pretty messy and that would not work. So remember, the intersecting point will always be in the middle. So our intersecting point over here is B. And over here in our previous example, it's P. So that will always be in the middle. Now, if you look over here in these two examples, I didn't include the middle variable. Why did I do that? Well, that's because it doesn't really matter. As long as you have the angle sign in the middle, in front of it, then it still means the same thing. Because if you went from A to C, then it's obvious you'd have to go to P because you can't just draw an imaginary line and go from there to there. So if you wanted, you could write this angle as angle AC or CA. So let's go through that one more time. Over here in our angle, ABC, CBA, AC, and CA are all identical, meaning they're all the same thing. Now, if you want, if you're wondering which one out of all four of these is most commonly used, well, that's a good question because usually we only use ABC or AC because mathematicians, they like to put everything in alphabetical order. So over here, most mathematicians would use ABC or AC. So let's finish our list over here. The angles formed in this figure is angle AD, angle CB, angle BD, because we like to put it in alphabetical order, and lastly, angle AC. So these are our four angles which we have found. Well, now that we've talked about the different types of angles, well, we haven't talked about different types of angles, we've just talked about what angles are. But angles are a part of math, meaning they have measure. So does that mean, can we measure angles? Do you think we can measure angles? Well, if your answer was yes, well, then you're right. We can absolutely measure angles. And we measure them using a few different units, which are degrees, radians, and I think that's it. There could be more units, but these are the most commonly used units for angles. Oh, that looks like one word. So there are two units for angles, well, that I know of, but in this video, we're going to be focusing on degrees. So, first of all, let's talk about different types of angles. Let's talk about right angles. So to show you what a right angle is, I'm going to use this figure that I have been provided with. So over here, do you notice how this is shaped like a plus sign? Well, when two lines are aligned like this, we call them perpendicular. What perpendicular means is that whenever two lines are joined together, they form a right angle. A right angle is 90 degrees, and what that means is that it can form a perfect square or rectangle angle. So, like, you see how that lines up perfectly? Because all the angles in a square or a rectangle are 90 degrees. So if you look over here in our diagram, over here, here, and here, they're all 90 degrees. So do we know how much the whole thing is? How many angles would the whole thing be worth? Well, to do that, let's just add 90 4 times. 90 plus 90 plus 90 plus 90 gives us 360. So this whole thing is 360 degrees. So that means a square or a rectangle is all the angles in a square and a rectangle are 360 degrees. Well, you might be asking me, how does this relate to triangles? Well, that's a good question, but they do relate. Because whenever we have a triangle, let me just draw a triangle real quick. Yeah, I totally drew that by myself. So, okay, how about I move this? So over here, the angles in this may not be 90 degrees, but they still are, well, they still have some sort of angle, right? We just don't know how much they are. But we do know that all three angles in a triangle. So let's call the three angles in this triangle X, angle Y, and angle Z, I mean. So angle X, angle Y, and angle Z sum together, meaning added up together, gives us 180 degrees. That is precisely this much of our figure. I'll call that a figure. Let's name this figure 1. Oh, that came out as a 4. Why did I do that? So this is our figure 1. And over here, that is a triangle. A triangle's angle is precisely this much of our figure. But a square is precisely this much. So squares and triangles have a lot of differences. So now let's talk about acute angles. So for the sake of acute angles, I'm once again going to be using a figure that I have been provided with. And yes, I did draw that myself, so please do not doubt my skills. But moving on, we can tell that this is 90 degrees or a right angle. Well, we don't need to be talking about right angles. We already talked about that. So acute angles are anything that is less than 90 degrees. So anything that is not 90 degrees but isn't bigger than 90 degrees is an acute angle. So an acute angle is less than 90 degrees. Or we could say a right angle, less than a right angle. So if we had an angle which is which looks like this, over here our angle is right here, and let's call it angle X. Angle X is acute because, well, it would only be right if it was going all the way up here. Oh, I should have used red. So it would only be right if it was perpendicular, meaning standing up straight. So our angle over here, angle X, must be acute. Now our last topic is obtuse angles. So, well, just like acute angles, well, not just like acute angles. Well, I'm going to use a figure that I've been provided with once more. Over here, obtuse angles are anything bigger than a 90 degrees angle. Bigger than 90 degrees. I shouldn't say bigger, probably greater. Greater than 90 degrees. So over here, 90 degrees is our mark. Now, anything that went over here, or even over here, that is an obtuse angle. So over here, this is one, this is one, and this is one. They're all obtuse angles. So, well, now that we've talked about angles, let's finally move on to triangles. Triangles can be sorted into two different topics. Under two different types, based on their angles and based on their sides. So let's take a break from angles because we don't like angles. And let's start by talking about how they are separated according to their sides. So let's take a triangle. Oh, it won't let me draw. Okay, let's just say all the sides in this are the same. So if I drew a line over here, or two lines, and I draw two lines over here and two lines over here, that means they're all equal. But for the sake of my hand, I'm just going to use one line. So that means all sides are equal. So this type of triangle is called an equilateral triangle. For the second triangle, I am going to have to draw one by myself using my amazing drawing skills. So over here, actually, let's do isosceles first. So I know that sounds like a complicated word, but trust me, it's pretty easy. Over here in this triangle, only two sides are equal. This one and this one. This one is not equal, meaning only two sides are equal. So in this type of triangle, we call it an isosceles triangle. Did I spell that right? Yeah, I did. Isosceles. Now in our last one, none of the sides are equal. So no sides are equal. So this type of triangle is called a scalene triangle. So there you have it, the different types of triangles based on their sides. I'm going to move this a bit more to the side. And this too. Now let's talk about how they are how they are separated based on their angles. So to show you how they are separated, to show you the first type of triangle based on their angle, I will once again, I don't want yellow. I will once again use a figure that I have been provided. So, I should probably move that higher up. So over here, all of the angles are less than 90. So, I should probably written that below. So all angles are less than 90. So this type of triangle is called an acute triangle. I should probably just write acute. So this type of triangle is called an acute triangle. Now, I will show you what, I didn't want this color. So the next type of triangle is a right triangle. So as it's pretty obvious in its name, it has a right angle in it. So this has a right angle. So keep in mind that a triangle can only have one right angle no matter what. You will never see a triangle that has two right angles. So this is called a right triangle. Our last type of triangle, I really hope I can fit this all in. Can I fit it in? I'll try. So our last type of triangle is an obtuse triangle. Why do I keep forgetting to switch my colors? So I am currently in the process of drawing my very precise obtuse triangle. What just happened? Okay, so here is my very delightful obtuse triangle. Over here, you see one angle is larger than 90 degrees. So it has an obtuse angle. And just like the previous ones, this is called an obtuse triangle. So this is basically the different types of triangles. Okay, so let's go through that one more time just so we know we're sure. Let's go through angles first. Angles. There are three types of angles. That is right angles, acute angles, and lastly, obtuse angles. And the different types of triangles can depend on their angles and their sides. So based on their angles, there are acute triangles, obtuse triangles, and lastly, right triangles. Based on their sides, there are equilateral triangles, isosceles triangles, and lastly, scalene triangles. So, thanks for watching this video. I hope it helped, and be sure to drop a like and subscribe.